everyone. Welcome to Math Wizards 123. This is take 2 on our live stream for solutions of equations. And we'll just take a look here and see. I'll give it a minute to see who's still in the room with me. And then we'll figure out whether this is still lagging or if we're good to go. Yeah, technical difficulties. Okay, guys. Okay, I can see some of you in here, but I'm just waiting for it to pop up on my computer. Hold on one second. I'm going to reload and see what I can do here. Okay, I think we might be in business here. Let's see. Hi, Alice. I can see you there still. And I think that's Jacob. Hi, Jacob. All right, I'm just trying to figure, are we still lagging or are we good? Now, who's Mayla? I was trying to figure that one out last week. Who's Mayla? Or Mila? You can type your first name into the stream just to say hi to everybody. That way we know who you are. Yeah, paper would be good. After I show you the first part with this equation, then we'll practice about 3 or 4 problems where you just plug in the numbers. So it'd be good to have a piece of paper and a pencil. And I'm going to give it a try here. If it continues lagging, then I might need to try going back and filming at home. But let's give it a try and see what happens. So if 5,3, is 5,3 a solution to this equation right here? Well, what I want to do is find out if this point on the graph here, on the coordinate grid, is it going to fall on the same line that this equation, if we graph this equation, is it going to fall on the same line is basically the question that I'm trying to figure out. So you don't need to copy anything here. You can just watch me for the first problem, and then once I turn the page, then you can come in with me here. So let's take a look at this equation. If I want to try to draw a straight line using this equation, what if I plug in the value of 1 for x? Well, remember that whenever you have a number sitting next to a variable, you're going to multiply those two numbers, right? So what would y be if x is equal to 1? Go ahead and type in a number that you think might be the value of y. A little bit of lag, I can see that. If you know what the value of y is using x as 1, go ahead and type that in. Still lagging. Okay, I see a 2 there, so I'm going to plug this in. That gives me the ordered pair of 1 and 2. The first value is always going to be the x, the direction you go on the x-axis, and then the second number will always be the distance you're going on the y-axis. So what if I plug in the number 2 in this equation? What would the value of y be? So if I have 2, and I know that this is going to be multiplied by the 2 sitting here, what would y be? Oh, is that Camilla? Okay, I see a 4. That makes sense because 2 times the 2 equals to 4. So then my ordered pair would be 2 comma 4. what happens if I plug in a 3 into the equation? Then what would the value of y be if I plug in a 3? I'm just waiting for the lag to catch up. Okay, what would y be if I plug in 3 into this equation? All right, I see some 6's. That makes sense. 2 times 3 equals 6. So then our ordered pair would look like this, right? Now, if I come over to my grid here, if we start at the origin, which is right in the center, if I want to just put this point, this ordered pair, graph it as a point, then I'm going to start at 0, and I'm going to move the x value first, which is 1, so I can move over to 1. I kind of hold my finger there. And then the y value is 2, so that means I'm going to go up 2. So I can pull out a point right there. I can do the same thing with the other 2. So now I'm going to plot this ordered pair on the grid and see where it lands. So 2 is my direction first on the x-axis, and then 4 is a positive 4 going up this way along the y-axis. So here's the x-axis, this is our y-axis that we talked about in class. Now if you look at the next one, 3, 6, to plot this ordered pair, I start again back at 0, moving over 3, and then up 6. Now what I can do is I can take a ruler and then I can draw a line that goes through all of these points to see what other values would also be falling along this line, right? So I can create a line by just connecting the points. The question is, does this point for the ordered pair 5, 3, will that fall on this line that we created when we graphed this equation? So now I'm going to go ahead and just plot the point. So to plot 5, 3, I'm going to start at 0, moving over to 5, and then up 3, and look where that lands. Okay? And the way I can prove that this is not a solution, it does not land on the line created by this equation, is I could also take the value of 5 and I could plug it in here and see what do we get if we plugged in 5 into this equation. What would the y value actually be? So can you figure out what the value of y is if I plug 5 in here? It seems like there's a little lag, so I'm going to give it a minute here. I want to figure out what the value of y is going to be if I plug 5 into the equation here. Okay, I see a 10. That would make sense because 5 times 2 would equal 10. So this ordered pair would fall along this line if I went ahead and plotted it, all right? But they're asking us, is 5, 3 a solution? So then my answer would be no. 5, 3 is not going to work. It's not a solution because it doesn't, this point right here that we graphed for these directions, x being 5 and the y value being 3, it doesn't fall on this line. So what we're doing is we're looking for solutions that actually will fall along the line. Now there's a quicker way that you can solve these. So let's take a problem like this one. I'm going to just separate this in half here. We'll try to do 4 more. How's the lag going? Are you guys seeing me now? You can give me a thumbs up if everything is working fine. It just seems a little slow today. I'm watching the video on my other computer and it's still showing the last problem we were doing. I'm going to go ahead and write this out here so I can get it ready for you guys. So we're going to look at this equation and try to figure out whether or not this ordered pair would be a solution that would actually fall on the line if this equation was graphed. Yes, you can go ahead and grab your pencil and paper and try these out with me. So I'm going to ask you to show the steps of how we can figure it out using just the equation and our numbers. So we're not going to graph it this time. We're just going to check it using the numbers. So if I look at the numbers, I know that this value here is x and this value on the right is always the y. It's telling you what the directions are when you plot a point. But instead of graphing it, we can go ahead and just plug in the values. Now, I know that when a number is seated right next to a variable, that's always means multiplication, right? So I have to just remember that. If it helps you, you could put a little dot in there to remind yourself to multiply once you plug in the values, but we're just going to substitute the values in now. So for x, I'm going to go ahead and substitute 0. I'm going to use parentheses to remind me. Keep the 4 next to it. I copy the equal sign, and then when I get to the y value, now I'm going to substitute this number, 4. So then I can go ahead and do the multiplication and see what happens. 4 times 0 is 4. So now when I look at this, this is not equal to that. So what we do is we go ahead and draw a line. Oh, it's lagging again. Sorry guys about all this lagging today. I'm just going to give it one more try with another problem, and then if it's still lagging, we're going to cut the stream, and then we'll try it again probably tomorrow. Let's see what happens here. Yeah, I'll just give it a second to catch up. Are we fine now? Okay, I think we're in business, maybe? Yeah, when I'm watching on the computer, it's coming out slower. Okay, so then this is not a solution. So the answer would be no. This ordered pair, that would be a point that would be far away from the line that would be created with this equation. So this is not a solution. They have to be the same. They have to be equal on both sides. So let's try another one here. Y equals 3x. And we're going to check and see if this ordered pair, if I graph this point on a coordinate grid, would it fall on the line that's created with this equation? So we're going to go ahead and just substitute in. I can start with just labeling them. It's nice to put the x and the y up above here so you don't get confused where to put everything in. So the x value is going to go right here. I'm just going to plug that in with parentheses so I remember to multiply it by this number. And then the y value, which is a 6, is going to go here. And then I go ahead and take care of the multiplication. 2 times 3 is 6. So when I look at this, I know these are equal to each other, so the answer would be yes. This point, 2, 6, for this ordered pair would actually fall right on the line for that equation. Okay, give me a thumbs up if you're still with me. Because now I'm not seeing any movement on the chat. I'm going to go ahead and post 2 more problems, and then you can try these on your own. Okay, and you're going to check and see if this ordered pair is a solution to this equation, and you can check and see for this one here. And my lights just went off. Okay, 7x plus 12 And then I'd like you to check for this point right here. Does this one fall on the line? Okay. So go ahead and substitute in your x and your y value. Now for this one, you have to remember to use your PEMDAS because there's more than one operation here. So if you need to list that over to the side, you can. Because I can see multiplication here and I can see subtraction, so I need to remember exactly which to do in order, right? Okay, so I'm going to go ahead and start plugging in. I have a 3 for the x value, so I'll wrap parentheses around it to remember to multiply. And then the y value, they're showing me is 5. So now I just need to see if when I calculate this, does it actually equal to 5? So what do I do first? Should I multiply? Should I subtract? I'm going to look at my PEMDAS over here and see. I know right here, we're going to multiply and divide first. So this becomes 15 minus 10. And then for the final calculation, we just take our last step of PEMDAS, add or subtract. So we're left with 5. So the answer here, I got yes. Okay, good job. So that makes sense because when they're both equal to each other, then we know that this point right here, if I graph that point, it's definitely going to fall on the line. Okay? Good job, you guys. Thanks for all your patience with all the lagging. Try one more before we end the stream. See how you do with this one. Sorry, Max. This is really, you guys have a lot of patience on this one today, that's for sure. Okay, good job, Carlos. We definitely multiplied first here, and then check on the same, in the same way over here. I can see two operations, right? This is multiplication, and then you have addition. So if you need to write these out again, you can set it next to the problem like that. And I like to write the x and the y next to the numbers, so that way I don't get those mixed up. Okay, so you can go ahead and plug these in and see what you get. I'm going to just put the 2 in here and set it up, and then I'll let you guys figure out whether or not this is a solution. Let's see what you think. Okay, I think so. Lexi has a no so far. Can you tell me why you decided that it's not a solution? Okay. What did you get on the other side of 0? Okay, I see someone with a 31 not equal to 0, someone with a 28 not equal to 0. Carlos has a no. So it seems like you're all agreeing that it's a no. So I think we need to check the PEMDAS to see what is the value we're getting on the other side. So PEMDAS tells me to check parentheses, then exponents, and then multiply and divide first, moving from left to right. So 7 times the 2 gives me a 14 here. So then this would be what we would need to add together. So we just need to check our calculations there. And I see another 20, let's see, I see a 28. Yeah, 14 plus 12. And then once we figure that out, it's obviously not going to be equal to 0, but it is 28. So somebody who had 31, you were close there, Max. But either way, these values are not equal to each other, so it's definitely going to be a no. So this point, if I graph 2, 0 on the grid, it's not going to fall on the same line if we plugged in numbers for x's and got our y's for this equation here. So we're going to say this is a no on that one. All right, good job, you guys. Nice work practicing. I'll try to give you a quick song here if you want to give a little wave out. Hopefully it won't lag anymore. Okay. And then we will see you next time, hopefully with less lagging. And we'll see what else we can do to practice some more with equations. But you did a great job today figuring out whether these are solutions or not. Oh, 26, here, let me come back over. We had a 28 and I'm seeing a correction already. There we go. If we stack it, we can see you've got a 26 there. Good catch on that. We had a few people, I think, had, or a couple people had the 28. That's okay. Good catch. Bye, Emmanuel. Good work, Max. And we will see you next Wednesday at 4. Bye, guys.